You've hardened your perimeter. Multi-factor authentication everywhere. Zero trust network architecture in deployment. Your team is running penetration tests quarterly. Then a software update arrives from a vendor you trust completely. The company that makes the network monitoring tool used by your IT team. You approve the update. It installs automatically across your environment. And inside that update, invisible to your security stack, is a backdoor that has been sitting in the vendor's build system for months. You just let the attacker in, and so did 18,000 other organizations, all at once. This is SolarWinds. SolarWinds is a Texas-based company that makes Orion, a network monitoring platform used by government agencies, Fortune 500 companies, and critical infrastructure operators to monitor their IT environments. In late 2019 or early 2020, Russian intelligence hackers, the SVR unit known as Cozy Bear or APT-29, gained access to SolarWinds' internal build system. A build system is the automated infrastructure that compiles source code into software updates. The attackers inserted their malware, later named Soonburst, directly into the Orion build process. Every update compiled after that point included the backdoor, digitally signed by SolarWinds' own certificates, completely legitimate by every technical measure. The update was distributed in March 2020 through SolarWinds' normal software delivery channels. 18,000 organizations downloaded and installed it. The list of victims reads like a security clearance nightmare. The US Treasury, the Department of Homeland Security, the Department of Defense, the State Department, the National Institutes of Health, Microsoft, Intel, Cisco, and hundreds of others. None of them had been directly attacked. None of their individual security controls had failed. They trusted SolarWinds. SolarWinds had been compromised. The trust transferred. Soonburst was engineered for stealth above all else. After installation, it waited. 2 weeks. No activity, no network calls, no behavior that would trigger detection. This dormancy period was designed to separate the malware's installation from its activation in time, making correlation harder. Then it began low and slow reconnaissance. It inventoried the network, collected system information, and checked whether it was running inside a security research environment. If it detected analysis tools or known security researcher domains, it deactivated itself. It was built to survive sandbox analysis. Command and control traffic was disguised as legitimate Orion telemetry. The malware communicated with attacker infrastructure, using the same kind of network traffic that Orion normally generates, monitoring data, status updates. To any network monitoring tool examining the traffic, it looked like the software doing its job. The command and control domains were registered in advance and aged to appear legitimate. The DNS requests were structured to avoid pattern detection. The attackers spent months studying Orion's network behavior to make their malware's behavior indistinguishable from the real product. The breach wasn't discovered by any government agency. It was found by FireEye, a private cybersecurity firm, in December 2020, 9 months after the malicious update was distributed. FireEye discovered the compromise because the attackers were using their stolen red team tools on another victim. The discovery was accidental and private sector driven. FireEye notified Microsoft and the US government. The full scope of the breach took months to understand. Some affected organizations likely never discovered they were compromised. The dwell time, 9 months of active access before detection, is what made this one of the most damaging espionage operations in history. The security industry's response to supply chain attacks has focused on software supply chain integrity. SLSA, Supply Chain Levels for Software Artifacts, is a framework developed by Google and adopted by the CISA that defines a set of controls for software provenance. Who built the software? What source code it came from? What the build environment looked like? The goal is attestation, cryptographic proof that a software artifact was produced by a known, trusted process. SLSA compliance doesn't prevent a sophisticated attacker from compromising a build system, but it creates audit trails that detect unexpected changes. Vendor risk management has to include the vendor's build infrastructure. Organizations that perform security assessments on their software vendors typically ask about application security, penetration tests, vulnerability management, patch cadence. The SolarWinds attack originated in the build pipeline. Most vendor security assessments don't reach that far. Post-SolarWinds, sophisticated buyers are asking, how is your build system protected? Who has access to it? Is it air-gapped from the internet? Is code signing performed in a hardware security module that can't be accessed by a compromised developer workstation? These are now legitimate procurement questions. Network segmentation limits the blast radius when a trusted vendor is the entry point. SolarWinds Orion required broad network access to do its monitoring job. That access is what the attackers leveraged for lateral movement. The principle of least privilege applies to software tools, not just user accounts. Monitoring agents should have the minimum network access required for their function. If a monitoring tool is compromised, it should be unable to reach your most sensitive systems. Privileged access workstations, network segmentation, and regular review of which systems your software vendors can reach are all post-SolarWinds lessons that most organizations implemented slowly. The genius of the supply chain attack is that it turns your defenses against you. Every firewall rule, every access control, every security tool you deployed, all of it was configured to trust the vendor that was already compromised. The attacker didn't defeat your security. They used your security's own logic to get in. You approved the update. Your code signing validation confirmed the signature. Your network monitoring tool reported everything normal, because the monitoring tool was the attacker. If you want to understand how Zero Trust architecture specifically addresses the trusted vendor problem and changes what happens when the update that arrives is already compromised, our video on Zero Trust explains exactly how that access model works. A trusted update is only as safe as the trust behind it. Zero Trust architecture, the security model. Every company is now scrambling to adopt explains how organizations stop trusting the vendor by default. It is on this channel.